the 5.98, sorry, 5.98 times 10 to the 24th times the mass of the sun over r squared. Don't forget to square this. That would be 1.5 times 10 to the 11th. Make sure you put it into your calculator correctly. You should get, if you solve for m, about 1.98 times 10 to the 30th units or kilograms. There's a lot of steps I skipped, but honestly, I don't need those steps if I have the equation substitution with the correct units, which I don't quite have because that is meters, and I have an answer with the right units. Okay. We are now about half an hour to the video. Thank you for hanging in here for so long. We have about 10 more questions to go. Base your answers to questions 62 and 63, blah, blah, blah. A car traveling at a speed of 13 meters a second accelerates to a speed of 25 meters a second in 5 seconds. Calculate the acceleration. A is the change in velocity over time. In this case, delta V would be, you could do V final minus V initial. 25 minus 13 gets you 12. It says I should show my work. I'm sorry. So 25 meters per second minus 13 meters per second over 5 seconds gets me 12 over 5, which is equal to, 2.4 meters per second squared. 2.4 meters per second squared. This is all kinematics. I don't know why it's in here, but let's finish solving it anyway. A truck traveling at a constant speed travels the same distance as the car in the same 5-second interval. So if it's constant speed, d equals vt. We want to find the speed of the truck. V is equal to the same distance over the time of 5 seconds, which tells us we need to actually find the distance for this too. So different ways to do it, but let's just think about it this way. D for this is going to be average velocity, and the average is halfway between 25 and 13. So I could say, put this in here, 25 plus 13 divided by 2, get the average, is, 25 plus 13 divided by 2, 19 meters a second, times 5 seconds, it's 95 meters. So D is equal to 95 meters. So 95 meters divided by 5 seconds gets me 19 meters per second, which is ironically the same as the average velocity. Or not ironically, because it's bound to happen that way. Okay, scale diagram. Two forces, F1 and F2, act on a 4 kilogram block at point P. Force 1 has 12 newtons and is directed to the right. Determine the magnitude of F2 in newtons using a scalar. So scale diagram. So I actually need to find myself a ruler. Pause. Okay. So let's look at this. 3.5 centimeters. 3.5 centimeters equals 12 newtons. So divide both by 3.5. And I get 1 centimeter equals 3.4 newtons. That's my scale. So this particular one, which is equal to 2.6 newtons, 2.6 centimeters, and each centimeter is 3.4, gets me about 8.9. So we're going to say 9 newtons. I am guessing if you looked at the original question this drawing came from, it would have been much nicer. Like the scale would have been bigger. Regardless, we've got 12 to the right and 9 to the left, so that gives us 3 newtons to the right. Now it asks for magnitude, so really we only need to give 3 newtons is the magnitude. And finally, the acceleration of the block. Acceleration is net force over mass, which in this case is 3 newtons over 4 kilograms, 0.75 meters per second squared. Doesn't ask you to show your work, so you don't actually need to use units if you really don't want. Here, they have a sports car that accelerates from 0 to 60 miles per hour, and it gives us meters per second too, in 3.75 seconds. It asks us what the normal force is. Well, the normal force is equal and opposite to the weight, and it actually tells us what the weight is. The mass is 1250. The weight is 12300. 12300 newtons. How convenient, they actually told us in there. The coefficient of friction between the car's tires is 0.8. Find the maximum force of friction between the car's tires and the road. So, in this case, the maximum force of friction is going to be depend on F sub F equals mu times the normal force, and tires in the road is 0.8 times 12300 newtons gets us 9840 newtons. Okay. Using the value for forces I've calculated, explain whether or not the manufacturer's claims for acceleration is possible. Okay, so let's think about this. F net, because your net force is going to be caused by friction. Net is ma, which is 1250 times the acceleration, which is the change in velocity over time. So 0 to 28.6. So the change is 26.8 meters per second. To change in velocity in 3.75 seconds. So this is a complicated question. But we're saying that the net force then is 1250. In order to achieve this acceleration, you need a net force of 1250 times 26.8 divided by 3.75. Basically, we need a net force equal to the mass times the acceleration that they claimed to have, which was 0 to 26.8 in 3.75 seconds, which gives us a net force of 8933 newtons. So the question is, can friction provide enough force to supply this net force? And the answer is yes. And the reason is because the frictional force, the maximum frictional force, is bigger than the net force. So friction can apply more than 8,900 newtons worth of force. So FF max is bigger than the net force that they claim that you need. Okay, that's a tricky one. I guarantee that. Hopefully you won't see a question like that on a Regents exam. A soccer player accelerates a half-kilogram soccer ball by kicking it with a net force of 5 newtons. Calculate the acceleration of the ball. Acceleration is going to be net force over mass, which is, let's see, net force, 5 newtons over mass of 0.5 kilograms. Should be 10 meters per second squared. What's the magnitude of the force on the soccer ball on the player's foot? Well, third law says if they applied 5 newtons, the ball will apply 5 newtons back. Pretty simple. Almost done. a force of 10 newtons to the right is exerted on a wooden crate initially moving to the right. The crate weighs 25 newtons. Calculate the magnitude of the frictional force. It's a wooden crate on a wooden floor, and it is moving. That's important because in that case, F sub F is going to equal mu times the normal force. And mu, if you look on the reference table, is 0.3 for a wooden crate on a wooden floor if it is moving. It ends up being 0.42 if it's not moving, but that's not an issue here. And normal force, it's 10 Newton box. 10 newtons is going to tell you the weight, 10 newtons. So the magnitude of the frictional force is 3 newtons. 3 newtons. Draw and label all vertical forces acting on the crate. We don't need to do horizontal forces, so vertical forces would be your normal force and your weight, F sub G. There we go, normal and weight. Let's see, if it's going to the right, label in all horizontal forces. Okay, there we go. So 10 newtons, by the way, this is a 10 Newton box, so we said down and up are 10 newtons. Oh, I made a mistake. My bad. Okay, not reading it carefully. The cart weighs 25 newtons. So scratch this. 0.3 times 25 newtons should get you 7.5 newtons of frictional force. So that's 7.5. My bad. Okay. So that would be, let's see, 25 newtons down, 25 newtons up. You're applying a 10 Newton force, and you have a frictional force that is backwards, and that force of friction is equal to 7.5 newtons. Okay. What's the magnitude of the net force? Well, that 25 up and 25 down cancel each other out. So then you have 10 to the right and 7.5 to the left. 10 minus 7.5 gets you a net force of 2.5 newtons to the right. So is the cart accelerating? Yes, definitely, because it has a net force of 2.5 newtons. If it had zero net force, it wouldn't be accelerating, but it is. Okay, last but not least, the diagram below shows a 5 kilogram block accelerating at 6 meters per second squared along a horizontal surface by the application of an applied force of 50 newtons. It is accelerating. That's important to note, and we know the acceleration. What's the magnitude of the force of friction? So we know the mass, and we know the acceleration, so we can find the net force, which is mass times acceleration. So in this case, 5 kilograms times 6 meters per second squared gets us a net force of 30 newtons. So if you're applying 50 newtons and you have a frictional force backwards, 50 minus whatever your frictional force is going to equal your net force. So 50 newtons minus your force of friction is going to get you 30 newtons. So force of friction is then going to be 50 minus 30, 20 newtons. Good deal. That is it. Thank you very much for hanging with me for this fairly long description. If you've got any more questions about any of these, please by all means let me know. Thank you so much.